Okay, so we're looking at the strength of gravity on different planets. And remember that there's nothing special about a planet. It has gravity just because it has mass. And planets are very massive things. They have a lot of stuff, a lot of matter in them. And Earth has quite a bit. So that if you were to use put a kilogram on the surface of Earth, it would feel a force of 10 newtons. So the strength of gravity, the gravitational field strength, is 10 newtons per kilogram. 10 newtons force for every 1 kilogram. Whereas on Jupiter, it's quite a bit higher. It's 25 newtons per kilogram. And on Mars, it's quite a bit lower, 3.7 newtons per kilogram. And Mercury is about the same, 3.8 newtons per kilogram. So if I was carrying a kilogram on Earth, I would feel the normal force that I'm used to, which is actually 10 newtons. And I would say, oh, it feels like I'm carrying 1 kilogram. But the force is actually 10 newtons that I'm feeling. Whereas on Jupiter, the force would be 25 newtons for the same 1 kilogram. And for Mars and Mercury, they'd be about 3.7 and 3.8 newtons for the same 1 kilogram. So I'll be carrying the same thing, like a bag of sugar, and those are the different forces it would feel. So what we did is we looked at this question here. What force would it feel like what force would you feel if you were carrying 5 kilograms? Well, 125 newtons, because because weight is equal to mass times gravity, which we looked at earlier on. So it's weight is equal to mass times gravity times the strength. When I say gravity, I mean gravitational field strength. So on Jupiter, the weight is equal to the mass 5 times 25. Okay, 5 is the mass and 25 is the gravitational field strength. So, and that's going to equal to 125. And the unit is newtons, because weight is actually a force, not and we say, oh, weight's measured in kilograms, but actually that's kind of not how we think about it in science. We think of it it's a force, actually. I'm just going to move this thing out of the way at the moment. So next it says, let's get rid of that. It won't feel like carrying. Because it won't feel like carrying 5 kilograms, because I'm used to 5 kilograms actually being 50 newtons on Earth. So what would it feel like? So if it feels like a force, if it's going to produce a force of 125 newtons, what I've got to ask is, when I say what mass would it feel like, is what mass on Earth would normally produce a force of 125 newtons? So we draw it like that, and we say, let's imagine this is on Earth, 125 newtons. What would the mass be to make that? It would be 12.5 kilograms. Why? Because weight is equal to mass times gravity. This time we know the mass, so we can rearrange the equation. Let's draw a slightly bigger triangle here. These are formula triangles before. Have you seen these before? So I'll finish drawing. You have seen them, yeah, good. So you look at the formula. What I would always say, let's get rid of that W first. Is you look at the right-hand side of the equation, m times g, and then I know where to put that, and they both go at the bottom because they're multiplied. And then in the gap, which this time is at the top, I put the thing on the left, which is W. So in this question, I'm saying, what does it feel like? What is the mass? What mass would it be? Well, I would be covering the m, and I've got weight divided by gravity. So m is equal to 125 divided by 10, which is 12.5 kilograms. Oops, which you've got up here. So yeah, so you've got, so basically, let me just click on that. So we know, so on Earth, 125 newtons would produce 12.5 kilograms would produce a force of 125 newtons. In other words, it would feel like on Jupiter, if I was carrying 5 kilograms, it would feel like carrying 12.5 kilograms, because that's what mass would normally produce that force on Earth. Does that make sense? Okay.